All right, Chapter 4, Body Organization and Homeostasis. In this chapter, we're going to cover from cells to organ systems, skin and organ system, and homeostasis. So starting off, we've been slowly working our way through the different levels of biological organization. We started with atoms and molecules, worked our way up to organelles and cells, and now we're going to start focusing on the next level of complexity. That would be tissues. Tissues are going to be a group of cells that work together to perform a common purpose or function, and there are four primary types of tissues that are going to be found in the human body. The first is epithelial. It's going to cover large body surfaces, lines, cavities, and organs, and form glands. So for example, the lining of the heart and the blood vessels, the lining of the mouth, esophagus, stomach, intestine, our outer covering of skin, the glands like thyroid, salivary, sweat glands, all of those are going to be considered epithelial tissue. The next tissue is going to be connective tissue. Connective tissue stores fat, plays an important role in immunity, and provides the body with protection and support. Muscle tissue is going to be responsible for the movement of the body and materials throughout the body, and nervous tissue is going to conduct nerve impulses from one part of the body to another. It's going to make up the brain, spinal cords, or made up of the brain, spinal cords, and nerves. So we're going to be focusing primarily on epithelial tissues in this chapter. Like we said before, epithelial tissues are going to cover body surfaces, line body cavities and organs, and form glands. And again, here's some example: lining of the heart and blood vessels, the mouth, esophagus, stomach, intestines cover skin, most of the thyroid, salivary, and sweat glands. One thing to note is that all epithelial tissues share two structural characteristics in general. One, it's going to be a free surface that can be specialized for protection or secretion, for example. So take a moment and look at some of the examples that we just stated. So out of the lining of the heart, the blood vessels, and all of those. So look at those examples. Which of these examples would be specialized for absorption? Which of these do you think would be specialized for secretion? And what do you suppose is specialized for protection? So just take a moment and look through some of these examples and see if you can figure out what their primary purpose is going to be. All epithelial cells also share a basement surface. So we have a free surface that can be specialized and a basement surface that's going to be used to bind the epithelial cells to the underlying connective tissues. This is going to help resist stretching and help keep the body or those organs intact. So here is a great diagram. This is going to show different types of epithelial tissues, where they might be found, what their purpose might be. They're ultimately going to be named for the shape of the cell and the number of the cell layers. So spend a little bit of time looking through this figure 4.1. Epithelial glands are going to be a little bit different. Glands are going to be composed of epithelial tissue that secretes a particular product. There are two types of glands that we're going to be looking at in this chapter. There are exocrine glands. Exocrine glands are going to secrete into ducts leading to body surfaces, cavities, or organs. That exo meaning out. So these are going to be secretions going out of the body. Think of things like sweat is going to be an exocrine. Endocrine glands lack ducts, and they secrete their products, specifically hormones, into spaces just outside the cells but inside of the body. So salivary glands would also be an example of exocrine glands. Nasal mucus, that's all going to be secreting out of the body or to the body surfaces or to the cavities or to the organs. Endocrine glands excrete they don't have ducts. They're going to be just sort of leaching their particular product into the space just outside the cells, but inside of the body. So they're going to be going into the interstitial fluid found in between the cells. So those are going to be our epithelial glands. Moving on to some of our other tissues, there is connective tissues. Connective tissues provide the body and its organs with support and protection. May also serve as a storage site for fat and plays an important role in immunity. There are a lot of different forms and functions. This is the most widely distributed tissue in the body. Cells are contained in an extracellular matrix of protein, fibers, and ground substance. What we're going to find in connective tissues is that we don't necessarily have a rigid organized structure as we do with our epithelial tissues, where we have layers and layers of cells stacked on top of each other. What we're going to find is cells sort of floating in an extracellular matrix. So you're going to see lots and lots of fibers, lots of protein fibers, and cells sort of suspended in that when we're looking at various connective tissues. And we're going to look a little bit at some connective tissues. So for example, connective tissues contain a ground substance. They're going to have fibers and then also cells. That ground substance is going to be non-cellular material. It could be solid like bone, fluid like blood, or gelatinous like cartilage. The cells are going to just be loosely distributed in that matrix amongst the fibers and the ground substance, sort of like a fruit in a Jell-O salad. It's just going to be sort of suspended in there. Fun fact, I'm not sure if you're aware of this, but blood is considered a connective tissue. This is why blood can be donated, but it cannot be sold. You can sell your plasma, you can, donate plasma for money, but you cannot donate blood for money, not legally anyway, because it is considered an organ. It's considered a connective tissue that cannot be donated for financial gain. There are two categories of connective tissue that we are going to be discussing. Number one is going to be connective tissue proper. Connective tissue proper is going to be loose and dense connective tissues. They're going to differ in their ratio of cells to extracellular fibers, but they're going to have sort of similar purposes. So loose connective tissue, adipose connective tissue, dense connective tissue. Loose connective tissues, like areolar connective tissues and adipose tissues, they contain cells, many cells, and very few loosely woven fibers. This primary purpose of loose connective tissues is going to be cushioning organs and providing insulation. Dense connective tissues are going to be found more in things like ligaments, tendons, dermis. This is going to be made of tightly woven fibers and is going to have more of a structural feature. Specialized connective tissues come in three types. Cartilage, which is going to be tough but flexible. It's going to serve primarily as a cushion between bones. Tends to lack blood vessels and nerves. So ultimately it's going to heal much more slowly than bone without those blood vessels, without those nerves. It's going to take more time to get nutrients necessary for healing. But it is going to serve that important purpose of cushioning between bone. Bone is also going to be considered a specialized connective tissue. Its primary role is going to protect and support internal structures, facilitate movement along the muscles, store lipids, typically within that yellow bone marrow, stores calcium and phosphorus, and produces red blood cells within the red marrow. Finally, blood. Blood is a specialized connective tissue. It's going to be a liquid matrix of plasma where elements of red blood cells, white blood cells, and platelets are just going to be suspended. Its primary goal is going to be transport of various substances dissolved in that plasma. And here's a fantastic diagram of figure 4.2 that's going to show all of these different connective tissues, where they're going to be found and what their role is. Muscle tissues are going to be ultimately responsible for the movement of body movement of substances through the body. It's going to be composed of muscle cells, muscle fibers that are going to contract when they are stimulated. There are three types of muscle tissue. They're going to ultimately vary in structure, location, and whether they are considered voluntary or involuntary. The first is going to be skeletal. Skeletal muscle tissue is attached to bones, moves the body, and is under voluntary control. Cardiac muscle, on the other hand, is only going to be found in the heart. It's ultimately responsible for pumping blood to the rest of the body, and it's ultimately considered involuntary. You have no conscious control over your cardiac muscle tissue. Smooth muscle is going to be found in the hollow walls of or in the walls of hollow organs. So for example, the stomach, blood vessels, bladder, uterus. This is going to be used to propel substances or objects through internal passageways, and again is going to be considered involuntary muscle movement. Spend a little bit of time with table 4.3. It's going to be a great summary table of all the different types of muscle tissue. Last, we're going to talk about nervous tissue. Nervous tissue makes up the brain, spinal cord, and nerves. Nerve tissue is ultimately going to be responsible for conducting nerve impulses from one part of the body to another. And it consists of two different types of cells. Neurons, which generate and conduct nerve impulses that can be conducted from one cell to the next. This is going to be used for passing information along. But more common than neurons is going to be neuroglia. Neuroglia are actually going to be responsible for supporting, protecting, and insulating the neurons. They're going to speed up the rate of nerve conduction in cells. So they are going to have more of a support role, but there's considerably more neuroglia than neurons. Here we have a table of junctions that help show sort of how we can use these tissues formed together to form, or how these tissues can be used together to form an organ. What we'll find is that there are several different types of junctions that are going to hold tissues together. The first one up here is a tight junction. Tight junctions form leak-proof seals. They're going to be found between cells that are lining the urinary tract and the intestines. They're going to be really, really tight junctions. They're going to be sort of like a zipper on a coat. It's going to form in sort of an airtight seal. Adhesion junctions, they're more like riveted joints. They're going to be found between skin cells. So it's kind of more like buttons holding a coat together. They're going to allow a little bit more stretch and movement, give a little bit more elasticity. There still is a nice tight junction, but it's allowing for more movement. And then finally, gap junctions. Gap junctions are the last junction in between cells. Now, they're going to actually have small holes for connecting the cytoplasm of adjacent cells. This is going to form sort of like a tunnel that's going to allow very, very quick conduction of information from one cell to the next. We're going to find these most likely between cardiac muscle cells. That are going to allow for that rapid transfer of information from one cell to the next. As we move up from tissues, we're going to hit organs. Organs are going to be composed of two or more different tissues that work together to perform a specific function. An organ system is going to be composed of multiple organs with a single common function. There are 11 major organ systems in the human body: the integumentary, skeletal, muscular, nervous, endocrine, cardiovascular, lymphatic, respiratory, digestive, urinary, and reproductive. Don't worry if that looks like a great big long list. We are actually going to spend some time going through every single one of these organ systems in the human body. So please earmark or come back to figure 4.7. 4.7 gives us a nice summary of all the different organ systems in the body. Maybe a great place to look to build flashcards off of, so that way you have just a general understanding of each of the different organ systems and what their primary role and responsibilities are. We're going to start off this chapter focusing on skin, the integumentary system. So here's where we're going to be spending the bulk of the time this chapter. All right, that's it for this section.